All right, so we are starting up section 4, and we're going to start the driving game. And we have 5 classes, and we'll have a quiz here on either the 2nd or the 3rd of May. And the quiz will be just on section 4, which is on the driving game. So, if you haven't already, go into Unity Hub, create a new project, just a basic 3D project, and then you're going to want to go to Package Manager, and I already went through the process of installing it all because it takes a long time. So you would probably, I don't think it's in Unity Registry. Let me see. What are these things called? The micro games. This one has Karting. Okay. No, it looks like you first have to go to the asset store and then to the package manager. I have the link too. So you could just do that. Click the link and I'll get you to the asset store. Oh, that's right. The asset store is not. You can't use it here. So let's just go to the karting metagame, which I spelled wrong. Let's see. Go to the asset store and say, okay, this is what I want. Open it. And when you open in Unity Editor, your package editor will go to this. And you will have to import and then download. Which I already downloaded. So you download first, and then you import it into your empty Unity project. And it's going to show you a whole bunch of new assets that are coming in. That's great. And then it's going to say, here's a bunch of project settings we want to change. And you're going to say, great. And I'll clear out these warnings. They're not the end of the world. And so here we have karting. Looks like we have some machine learning agents, which we're not going to get into in this class. We have some mod assets that were used in building the levels, some rendering settings. This is a not used scene folder, and TextMesh Pro for good text, and a bunch of packages that we don't really need to worry about. Shader graph, that'd be interesting if they have some shader graph stuff. I hope so. Pro Builder is a really cool level prototyping, making levels with basic geometry. It used to be a third-party asset, but you need both them up. Mathematics is a new mathematics library. So it looks like they're making use of it. Some coroutines, AI navigation stuff. Cool. So let's go into karting. And looks like we got some animations, art, audio, add-ons. Okay, so different types of races and cars that are added on. Our modular track kit, physics materials, prefab scenes, scriptable objects. Take a look at those. Those are good to look at. Scripts. Timelines is just like a whole bunch of stuff's been animated. Like usually it's in cutscenes where it's not interactive. A bunch of like interactive tutorials, which I'm not covering. So let's go into scenes. Got gameplay gym. So this is where they did the ML training. They do have some tutorials on this if you're interested. Gameplay gym is interesting. Let me get into that later. But for now, I guess we'll just go to main scene. Let me just play it quickly, make sure it's working. So let's see, current lap, best lap, here's some UI, you got tab for options. One sec, that like blew my ears out. It's super loud. Usually the audio, create engine audio. This is all the car stuff. Game manager. There, one sec. Let me see if I can see my volume mixer. It's better. Alright, there's a countdown, there's some music playing, some sound effects, like some beeping. My steering's working well. These objective rings disappear as you go through them. 2 out of 3. 1 left. Objectives complete. Cool. So the basics work. Forget to hit tab, but it's okay. So let's see. Let's go to intro first. Let's just see how all these scenes connect. So name your game. Got some controls. Play. Yep. Which everyone's doing. Play just goes into the main scene right away. Tab. Take a screenshot. Show a frame rate counter. That's cool. So you can see how they're calculating frame rates. That might be interesting. So I'm guessing lose and win are going to be just like the intro. Yeah, it's just like the intro screen. So those 3 we can cover quickly. Cool. And then I wanted to show you the physics playground. If you're interested in modding the game, this is really fun because you get to play around with all the parts of the level and other stuff, and you can bring this in, bring these parts in, or make a level here, or just add it into your other main level. So that jump is too big. Here's some like speed bumps. Side ramp. This jump here should be good. We got our speed down here. Here you can like really ramp, like my speed's kind of low, but you could really ramp up your speed. Give it a turbo boost or whatever. Looks like some like squealing sound when I get those skid marks going. It's like the squealing sound effects. These are kind of fun. Remember these big balls are fun to play with over here. So you can hit into them. They can hit into each other. So you got some more elaborate physics if we wanted to look into this. Cool. So there's a fun area. That was called the physics playground. And I just wanted to see scriptable objects would be good to cover. I don't think we really talked about them at length, except they're used pretty extensively here. I just want to look at the shaders. Art. Fonts, materials. Yeah, these materials are referencing just basic shaders. Oh well, they're just using basic shaders here. Doesn't look like. I was hoping for some shader graph stuff. You can look into that. So it's interesting to see how this thing works. And, it's just like the whole toolkit that eventually have a window. There's like a shader graph window where you could build shaders with nodes. I was hoping you could just look at a few, but it looks like they, I don't know why they imported it, because they haven't using it. And this, again, it's add-ons. Let me quickly just make a shader. Oops. No, interesting. They do have like the shader graph set up. It looks like they didn't make any shaders from there. I'm just looking around just one last time. Yeah, these are all URP, just basic lit. Alright, well, maybe I'll stumble upon them. Maybe they're add-ons. Oh well. So let me jump back to the main scene. Let me just take a look at intro scene. This is probably like super quick to knock out. Looks like we got a main camera. We got a UI canvas. We just have the player sitting on his player cart. And okay, he's just sitting out in the world. He's behind. So we have our big UI panel. Let me just see what it's doing. Screen space camera, and they just put a 3D object right in front of it. Him. Got a little light going in. Yeah, menu. These are the same scripts from the first-person shooter. And then we just have the player here. But notice how everything's been disabled. We just have this rotate on axis. So let's take a quick look at the script. Not responding. Okay, here we go. So if I click play, if I'm guessing correctly, it's just going to be rotating. So I can change the speed, and he'll probably speed up. But we have, just rotation about the y-axis. Yeah, he's just rotating this way. So you can ramp it up. You can make them rotate other ways. Get really dizzy. So real quick with rotational axis. So if you press the E key for move, so you can see he's aligned with the Z-axis. He's pointing toward the Z-axis. I think the camera is right. Yeah, the camera's like right behind him right here. And you can look at these kind of the color coordinates. So this is rotate Y because it's green, and as I rotate it, notice that the Y value is changing. I'm not sure why the positions are slightly changing. Something's a little off. Oh, maybe this is running while it's doing it. Anyway, blue is Z. And you can see he's rotating about the Z-axis, which he's pointing toward, and X would rotate like this. So it's hard to know like what each axis, how it would rotate about each one. So you kind of have to experiment to figure out like which one you want. In this case, the y-axis made sense. So what's happening with this script? All right, we have a public vector 3. And there's a little tooltip here. And this is very simple. Public class, this using Unity Engine. So on update, all we're doing is transform.rotate. So this is taking the transform component. You don't have to say like get component transform. our game object dot transform, like transform so readily available. So anyway, you just say transform, and there's the rotate method, and I don't know why I seem to have lost my I noticed this in the last class. I lost my IntelliSense. Just give me 1 second. Oh, I guess it just work without it. For right now, I have to try and troubleshoot this later. Anyway, so the transform component handles position, rotation, and scale. And there's a few different, you can choose to set the position directly. So you could just say transform.position equals whatever the position was last frame. This is an update loop, and then add a new vector 3 to it. So it's just adding a little bit based on your horizontal or your vertical input. You can do the same with so there's local rotation and local position and position's world position. And you can do the same with rotation. You could say transform.position. Notice it's a quaternion. It's not a vector 3, but quaternions handle 3D rotation well, but they're very complicated math. We don't actually mess around with that. But what we can say is we can set transform.rotation equals quaternion.Euler, and then pass in an x, a y, and a z. And that basically a vector 3. And it will create the quaternion for us, and we can set the rotation that way. And what you'll set, so that's rotation and local rotation. And you can do scale too, but we only have a thing called local scale right on that game object. But the two methods I'll point you out is look at and rotate. So rotate is take the rotation that it currently is, and let's rotate it. Let's add some more rotation to it, so it's additive. Usually you add a small rotation in the update loop, and you keep adding and adding. And look at means, hey, there's this object over there. I'm going to pass in this position, and you figure out how to rotate yourself toward it. I just want to tell you where this thing is you should be looking at, and it will figure out how to rotate your game object for you. So a lot of the nastiness of 3D rotation is kind of hidden from you, which is good. So rotate adds to whatever the current rotation is. I mean, just so happens he starts off at 0, 0, 0, but we add just a little bit of y for each update frame. And that's what's happening here. Rotation speed is a vector 3, and the other thing it's adding, it's just a little bit of y each time. So that's the rotate method. And that's pretty much it, because on the UI, we've already kind of covered this from the last class. There's just the controls image is turned on and off, and we have these buttons toggle game object to turn them on and off. And the start button just calls this load screen button. We're going to load up the main screen. So we just need UniEngine.scene management. And we're going to call this load target screen when we click that button. This button here, on click, call this, which is this. And we're going to load up the main scene, which we've already seen how to do that. Lose and win. It's the same thing, there's just not a 3D model there. It's just you lose, and then there's the buttons for go back to the main intro menu or go right back into the main screen. All right, pretty easy. Not gonna spend time with that stuff. I mean, easy enough since that you've been exposed to it. Just want to check if, yeah, game development's turned on. Interesting. Oh, something is not. I had to read set my computer, so something definitely didn't get connected. I'm just going to try the external tools. Yeah, this is a problem. Okay. Let's try that real quick. So, let's go into main screen, main game. Usually I start with the player, not like, so we do have the game manager, game flow, objectives, audio, time manager, pool initializer. So here's some news. A lot of these are from first-person shooter, but we have some new stuff. Like these are new. We'll take a look at those. There's some background music. We got our main camera. We got a player. Well, this is loading up. The player is going to have a lot of stuff underneath it. This cart's got like a lot of parts, definitely a lot of colliders. From this viewpoint, you can see like our game world way down here, the track. We have this UI. It's going to be, it looks like it's a much simpler UI than first-person shooter. It looks like we have this kind of skybox around us, and maybe some post-processing for effects, visual effects on the camera. And we got the track under here, the environment. We have some objective time limit, start finish line, a different game mode. Here's those 3 checkpoints I had to go through. And let's see, it looks, yeah, so this down here means like it's still loading up stuff. So I'm just going to leave that alone while I go back over here. So if I look around, looks like we have a bunch of calls, you know, around the arena circular. So maybe they're rotating them like this. And looks like under environment, we got trees and hills and clouds, stones, I guess all this stuff. The horizon. So it looks like we got these horizon mountains that keeps you in the game level. In the ground plane. And it's just a flat plane. And where's the sun that's sitting here? It's not part of. Huh. It's the directional. Oh, the mesh. Okay, they put a mesh sun, which is really just a quad underneath the light source. So here's the light. I'm trying to, okay, here. So if I rotate it, okay. So if the light source moves, it kind of moves like that. Alright, so it's before. Alright, so we have some nice organization here. We got level, we got game mode, player in general. So on the player, looks like this thing is still resolving a bunch of the search indices for the assets. Must be a lot. Cool. So under the player, we got a rigid body sitting on the top. Let's zoom in on them. So I'm guessing the ground underneath must have some type of like collider or something. So each of these tracks, okay, these tracks are like little modular parts. They've got a render. Okay, they've got a mesh collider. And they got a physics material. All right. So the cart's going to be interacting with this mesh collider, which that's very expensive. It should just be like some box colliders, one for each side, one for the floor. Mesh colliders are really expensive. Let's see the geometry real quick. Yeah, it's pretty expensive. Geometry's got quite a few triangles on it. Cool. So the player's got this big, got the rigid body. We have this arcade cart script, and we have this cart animation, cart player animation, keyboard input. So we have this cart Bouncing collider. All right, this big capsule collider has something to do with bouncing. We've got wheel colliders underneath this group. So let's zoom in here. So these are, it's kind of annoying, there's a sound. Okay, so here's the wheel collider. So if you notice, it's almost like 2D. It's flat. It's just like a flat circle. So we have these are kind of like advanced colliders that do a lot of stuff out of the box for you. So if I go into physics, we have all this type of stuff. And you've seen some basic stuff like box collider, capsule collider, maybe even like the character collider, and rigid body. But we have some like hinges, fixed like joints, springs, terrain, wheel, cloth for animation. So you have some different like physics bodies, the joints for a human body. But we're going to be, looks like, I don't know if there's like springs or hinges or stuff in here, but we definitely got this wheel collider. And you can look at documentation for it. So it's been specially built for ground vehicles, has built-in collision detection, wheel physics, and a slip-based tire friction model. Cool. If you want to learn more about it, there's a tutorial. And here's some properties that are exposed. And then, okay, so this is some of the other, so suspension spring. So if you wanted to like create like the vehicle suspension system, they must have this, okay, suspension, is that part of, I guess it's part of the wheel collider. Yeah, it is. Cool. So anyway, we have this wheel collider. Look at all the stuff, is all these properties that you just saw in the documentation. They set it up for you. We got 4 wheels. So we got some audio, arcade engine, all those different audio effects. And here's the different audio sources. For some reason, they had them on different game objects. Cart visual, so the 3D model. We have the cart. There's an animator sitting here. There's the cart body. So skinned mesh. So that means it's a 3D model. It's got a bone, a rig system, a bone system, and they've done animations that they've also in that third-party package that they've also imported in. And here's the root. Here's the bone structure. Root, cart face, what have you. So these are just bones. Usually there's nothing else in there. These just dictate how the animation gets played back. Then you have the player, who's got an animator too. Here's his bone system. Here's his skinned mesh renderer. And wheels. So it looks like wheels are separate than their colliders. They have a renderer. And they have a capsule collider sitting down the center of it, aligned with the vehicle. So that's interesting. So we have these capsule colliders mixed with their meshes, and then we have these wheel colliders that are separate. So we're going to have some crazy physics stuff to go through. I'll try to just focus on the concepts and ideas and not so much on the math. Let's see how it goes. So as you can see, there's a lot going on with the player. And his main interaction point is going to be these module pieces of road, as that's the collider that the wheels will be touching down on. So let me just check the time. All right, so let's go into, so it looks like there's no like hidden scripts. Sometimes there's these scripts down within everything. Let's just play the animations real quick, so you can start to break apart what's happening. The animations. Let's just open up the animator window too. And if I click on cart, So we have the idle. Looks like it's just put, 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 put. That's it. Okay. So there's just one, yeah, very simple animator. One layer, no parameters. It just goes into an idle. So I guess even if you're driving around, just the motor's just like put, put, put. Okay. Really simple. So player turn left. That's cool. So he's leaning into the left. Turn right. Jump. So he just lifts out of his seat. I haven't seen. Oh, I guess when you hit ramps and stuff, and when you're idle, you're kind of lurching forward. And so the animator has driving and jump. Okay, there must be like another something else going on with turning left and right. So steering and grounded. Okay. So yeah, there's a blend tree in here. So let me just see. We're driving, and notice it's not one file. It's like a blend tree. But the player jump is just playing one file. The player jump, and it looks like we go into a jump when grounded's false. Then we come back when grounded is true. It's pretty easy. So driving blend tree. We might have to spend some more time with this at a later date to really get into blend trees some more. But so it's a 1D, so you get more complicated ones, but this is just a one-dimensional blending, which kind of looks like a 2D representation here. But okay. So turn left, idle, turn right. And the threshold is probably based on that steering. It doesn't say steering, but I'm guessing this is coming from the steering variable. So this is, okay, that's missing. I think this was at 0. Okay, this lets you test your blend tree. So this is like a, oh, actually parameter. Boy, I'm blind. Steering right up here. Okay, this whole thing is based on the steering parameter, which is an integer, and it defaults to 0. And when it's at 0, we're at player idle. These lines indicate like how we're gonna blend. So so it looks like player idle is here, player turn left animation is here, player turn right animation is here. How do we blend between them? So I guess it's a 1D blending because you can only blend to the left and to the right, even though the graph is kind of a 2D graph. And that's just showing the transitions between them. So I can only move like, oops. I can only, that red line is like the playhead. And it's like saying, hey, let's preview what it means when steering goes negative. And here's like to -1. You can see him leaning left. And as steering goes to 1, you can see him moving to the right. We're transitioning between these three animations. We can only move left to right. So it's one-dimensional. And we're on the parameter steering. And here you could mess with these like lines on how, let's see, can you like add keys or something? I can only move this. You can only move this stuff. What's this? Okay, if you want to change animation speed up. Okay, so it's just a linear. It's like a lerp. It's like a linear interpolation. You can't like get fancy curves going in here. You just have to state their positions, and it'll like lerp between them. All right, so left, straight, right, and everything in between in a linear interpolation. Let me know if you have any questions on that. So there's a 1D blending tree that's all in here in this driving node. It's like blending between 3 animations, not just one animation in this node, the state machine node. Cool. So I went over the animator and the parts that are animating. And I'll start to look at this arcade cart. Let's step back a second. Arcade cart, cart animation, player animation, and key. Let's start with keyboard input. Okay, so it looks like we got some custom namespaces. That's great. So this is good for more larger projects. This project's a little too small for that. That's fine. So keyboard input is inheriting from base input. Okay. So base input, we have a struct, which is like something more complicated than a primitive type. It's like when you need multiple types connected together, you can make a nice little struct. And it's like a bool if we're accelerating, a bool if we're braking, and a float with our turn input. And this is an interface. You can think of it as an interface as like, so you see here that we have an abstract class called base input that's inheriting from mono behavior. So class is inheriting from other classes. That's good. Normally, you can only have one parent. So when you have a class inheriting from another class, you can only have one parent, and it does that to stop from really nasty situations like cyclical parent references and stuff. But you have a class that can only inherit from one class, right? Now, what happens if you want to inherit from multiple classes? Then you need to use interfaces. So this idea of classes and inheritance, and we have this idea of abstract classes, which means the whole class really doesn't have any definition. It doesn't have any code in it. It just might be like, hey, there's going to be some methods, but I'm not even going to tell you what those, the logic, like the body of those methods are. I'm just going to say, hey, there's going to be some methods, and here's like the return type and some name of it. But when they're abstract, it's like we're not even going to tell you anything more than that. Just like, here, here's a method. Here's the input you can expect. Here's the output you can expect. And I'll define it in the children later on. Okay, so it's an abstract class. And as you can see, our keyboard input will be inheriting this. And what's interesting is it's actually inheriting from two classes. So it's inheriting from mono behavior, which we've seen a lot. But it's also inheriting from I input. So it's inheriting from two classes, which is normally illegal. But this is what this concept of interfaces solves, is that you can inherit from multiple interfaces. And this interface is just I don't really understand the point of it, because it's just generating another method called generate input. But maybe as I read down into the children, this will make more sense to me. But anyway, this base input has this abstract method, has inheriting from two classes, and this other one seems to have another method declaration, but it seems to be private because it's no public or private. And so interfaces are kind of like abstract classes that you can inherit from multiple of them. And notice you don't even need to say like abstract all over the place. It's just like you're not even going to put any code in here anyway. It's just an interface, just saying, hey, there's going to be some methods that we'll define later. So anyway, we have this struct here, and we have this interface, and we have this abstract class that we'll be calling from in the keyboard input. So it's like saying, okay, we're going to have some string properties. The turn input, so it looks like these are dealing with input axi. So we're going to have horizontal input axi for turn input, whatever the accelerate and brake is. So if you go back here and go into maybe project settings and input. So accelerate is going to be mapped to up. and brake is going to be mapped to down. Okay. And we're going to override generate input, which you have to do that. You're going to inherit from base input, which is an abstract class. You need to like define whatever those abstract methods were. These down here. So we need to override it. Override this function to generate an XY input that can be used to steer and control the car. Okay. So we're overriding this method, and we have to use the same return type. And then we're going to say, hey, we're going to return a new input data. So if I go base input, input data is the struct that's been defined. And we're just saying, okay, it's going to be a new input data struct. And remember, it's got these three like components, these three properties. And so we're going to say, well, accelerate equals this, brake equals that, turn equals this. So it was like bool float. So input.get button, the accelerate, remember it's up. So this is only true or false. True when the getting is the button's being held down. Brake is the same thing. True when it's being held down or false otherwise. And then get access to horizontal A, D, left, right. And it maps to -1 to 1, basically, which so that's why it's a float. All right. And let me see how keyboard input's being used, and maybe I'll piece together why they separated this out. So I'm thinking only the arcade cart is referencing it, but we'll see. Cool. So this isn't being used. Looks like we're using some generic somewhere. All right. So within arcade cart, it looks like we have another class called stat power-up. So this is somehow dealing with power-ups. So why they chose this to be a class and not a struct, because it looks like it just has properties in here. I'm not sure why. But we've got a string, a float, and a float. And we've had an arcade cart.stats modifier. All right, so this is a struct. So maybe like a struct can't contain a struct type thing. So since there's a struct in here, the classes can contain structs. Let's try that. Oh, it's in the same file. Okay. See underneath there. So arcade cart.stats. So that kind of confused me. Like, yeah, see how it's blacked out? It says its name can be simplified. You don't need to, because it's within the same class. This struct down here, you don't need to give it like this namespace unless it was in like a different namespace. So these are both systems serializable, which let's look at later, why they made them serializable. But in either case, here's our struct stats. And notice that there's a bunch of headers and tooltips. So that gives me a hint that this must be exposed in the inspector. And I do know that if you need to expose structs in the inspector, you do need to make them serializable. We kind of talked about serializable is that process of breaking stuff down into bits that could be zeros and ones that are communicated between processes or computers. So here we have a bunch of floats. These are the stats. This is the stats of the stat power-up. So I guess there's a bunch of power-ups that can mess around with your top speed, your acceleration, your braking. I think these stats are also going to be used for the players. These are like, you can have your base stats, and then you can have stats that are like on power-ups that can manipulate your primary stats. So grip, steer, grip. Great. Now, since we have a public class stat power up, we have a public struct stats. Now, this is interesting. to talk about in that you can define operators. So even like an integer, like 2 plus 3 equals 5, even that type of operator, still somebody needed to define. So in C#, there is like something like a public static int operator plus, minus, divide, multiply, and like 2 ints can come in, and that's actually, they'd specify how just a basic arithmetic happens. So whenever you see pluses, like string plus, like a string plus a string, like somebody wrote the code for an operator, a plus sign for string concatenation. What does it mean to add 2 strings together? I don't know. Let's define the logic for it. The same with a vector 3 plus a vector 3. Somebody defined that operator and then wrote the code that actually, defines the logic for that. So every operator you see is what's called like syntactic sugar. It's like nice. It's human legible. Everyone understands the plus sign because it's part of our language. But that doesn't mean that the computer understands what that means. So even like an int plus an int or a float plus a float or whatever, somebody had to write the code that actually made that an operator. So that's a term, the operator. And it's like one type operator, another type, like int plus int, and then it's like, oh, I do have something defined for that. Let me run that code. So behind the scenes, operators are just methods. So the method name is just the plus sign. The input is an A and a B because there's something on the left, something on the right. And in this case, 2 stats come in, a stat comes out. So this is like, okay, the player's stats were these, but if it runs over a pickup, so A is like the player's primary stat numbers, and B is like the whatever pickup. Maybe the pickup was boosting acceleration. So all these would be 0, except this one here might be like a 2. So we're going to add 2 to our base acceleration for a certain amount of time. So this is how they decided to do power-ups in this game. So this is an operator that is defined for stats, and stats is this struct up here. There's an operator defined within its internal space scoping. All right, so we have a bunch of properties: rigid body, input, air percent. Let me just see where. Okay, so we do have base stats here. I'm trying to find like a lot of stuff exposed here. Oh, so here are base stats. Got it. Oh, so these are properties, but they have this get set, private set, so they're not exposed. Here's the first property that's exposed. Base stats of type stats equals new stats, which is a struct. And it just sets all these internal properties. And since it's system serializable, it's exposed in the inspector, and anyone else on the project can tweak the settings further to their liking. So you can open this stuff up, and if you're like, oh, this car is too slow, it can ramp up its acceleration. So base stats, I'm at 12. I can ramp it up even more. And then, I'm hitting at top speed. Let's ramp that up. Cool. And then notice acceleration is like bold because I changed it. And you can always revert it back. So that's interesting. Like this is back to what my default setting was. Oh, not me. Sorry. In here, it's whatever they set it out here in the inspector, so you can kind of pop it back. All right, so we got visual physics. You see that all there. Bunch of stuff you can look through and you can tweak. Some of them have been put into ranges. Suspension, physical wheels, the input sources. So here we're getting into some of the fields, private. Drift parameters. Look like this. We're now into the private area of the fields. It's a private set. A read-only list. So this is interesting. So this is basically like a field, but it's a list. So like you can't just instead of just a regular type, it is a list, and the list is going to contain 3 elements per element. So that's pretty interesting, if I'm reading that correctly. So later on, I'm going to see how these lists are working. But maybe for each element in the list, it's actually got 3 references to a game object, a wheel collider, and a trail render. But we'll see. But in any case, this is a list, and here's what it's like specifying it's a list of, and then we create a new list. But notice we can't use like get private set with that, so they're just saying it's read only. You can't change it. So we'll read on later on. Let's see if this, like how this list gets manipulated within this object. It looks like other objects can read it only, so why wouldn't, what's the difference between like read only and private? So we'll have to read up on that. So the cart can move. We got a list of stat power-ups and your final stats. So you have base stats and final stats. So this is like gets impacted by power-ups, and after a time limit, this drops back to base stats. All right, so you have some rotation, last valid position, collision. Then we have some methods, add power up. And these are like one-line methods. So add a power up. Remember, we see this arrow operator. So this just means it's a method, but it's just like one line, all put in one line. So we have these 3, and then we have some private methods. Activate drift, VFX, update drift, update suspension. Now we have our wake. Looks like we're going out, getting a bunch of our references as needed. Then add trail to wheel, add spark to wheel. We have a fixed update going through the suspensions of all 4 wheels. Gather inputs. Check if we're grounded. Here's our gather inputs method, tick power-ups, ground, airborne, reset. All right. So it looks like this arcade cart. So what happens is when a game object goes between different levels, sometimes you'll call the reset method. And this is like putting it, it's like putting its rotation. It's only concerned with rotation, just like rotate it back to its original rotation. Because it looks like the cart was used in like intro and the main scene, and even in that physics playground. All right, we got some local speed, and then we have a bunch of collisions. On collision, enter, exit, stay. Move vehicle. This is a big one. Oh, it's really big. Okay, cool. Finally reached the end. I just want to go to those read-only methods real quick because I'm interested in this. Let's see where they're being used. we're looping through them here. We're looping through it here. Here we go. Add trail to wheel. Do some stuff and then add. Yeah, we're adding one item, but that item has 3 parts to it. That's interesting. So it's almost like a struct. It's like you've defined that each element in the list will like function like a struct. It has like 3 references in it, one to a game object, one to a wheel collider, one to a trail. Okay, but I did want to, you can add to a list, you can modify it. So this read only up here is for other game objects. So you can read this list. Okay, I see how that's different from a private. So public is you have access to it, you can reference it from outside the object, and you can even change it. So public get means you can reference it. Now private set means you can't change it, right? So this means you can actually read it, but you can't write to it. A private, which this one is by default, means you can't do either. And like, I guess a list, it doesn't make sense to say public list, and then you would say this get private set. So in this type of situation where you want other objects to be able to read this list, but not to edit it, then you have something different besides public or private. You have something called read only, which means it's a public get. You can access this list from other objects as needed to like read it and get whatever you need. But you can't edit the list from outside this arcade cart object. Cool. So maybe I'll look at the awake. What happens when we first start up and we need to register? So go get the rigid body that's on this game object. Sets as property. Go get components of I input. Okay, so that's like saying go get this keyboard input because it's inheriting from my input and store it here. Update the suspensions of all 4 of our wheels, which pass in a wheel collider. And the 4 of them are listed out here. Somebody dragged and dropped them on. And we're just updating all these properties on it based on what we want to set our wheels to. Sure. Base stats. Go get the grip of our base stats. Set it to our current grip. If we do have some spark VFX, when we start off, add sparks to our. Okay, I guess add spark VFXs like prefabs. Same with the trail. So we're setting up our spark prefabs or trailing prefabs onto our wheels as needed. Trails only go in the rear. Same with the sparks. And if there's a nozzle VFX, instantiate it. I guess that nozzle, that's that thing that was pointing at the back, like where the exhaust thing that was puttering around. But what I'm really interested in is what are we doing here with these get inputs? Because remember, I kind of left that, like, what the hell is going on with it? So I'm going to look at that and probably wrap it up. So on awake, we're getting the I input, basically those keyboard input. Here on gather inputs, so gather inputs is called on 290. Is that any update? No, yeah, it is. It's called fixed update. So every fixed update gather inputs, which is kind of, I guess, I was going to say, should it be on input, or usually inputs are on input, but right. So equal new input data. So that's a struct over here. From our base input, we have this input data. Okay. So it's like, oops, arcade cart. Equal, create a new struct every fixed update. Okay. One trip flow. So for each of our M input, which is I input. So that's this thing here, this interface. So for each of them, call generate input. So call this and set input to each one. That's just weird. Wants to drift, I can skip for right now. Now he's just seeing if, based on our direct, like, is our velocity really getting off? Remember I did the dot product, it's like 90 degrees from our forward. We're really going into a skid. We want to go to drift. So the length of this I input, it's inheriting all the way to here. Generate input. This is why sometimes this over-engineering it I'm not a fan of, because it can really obscure code. Generate. So for each input, so there's an array of inputs called generate input. Oh, okay, because there can be more than one. Get component. I didn't read that. Get components. So I don't know why you would have more than one, but we just have one keyboard input. So it's kind of weird. Whatever. So it's like, hey, if we have more than one input component on our game object, we'll have to loop through each and call the generate input, but we only have one, this keyboard input. So this generate input here gets called, and it just creates a new input data, which if you remember over here, it's just a struct with accelerate, brake, and turn input. So just create a new one and set the 3 to this. Honestly, why do you need to do this more than once? Because you're getting these buttons in Axi and that's it. Like, you're not changing this at runtime. So I'm gonna go out on a limb and just say this is stupid implementation. And say you could have only you should have only done this once. You don't need to do this every fixed update loop. All you gotta do is you create your keyboard input once, right? And you got to call this generate input method. You should really only do this once. Create the struct once and be like, hey, look, we have accelerate, brake, and turn input, and this is what the keys are for it. And it's great. Wonderful. Just do it once. So maybe we are doing it in the awake. Not some fixed update. This should just be in awake. Because it's pulling these all in. Okay, so every fixed update, I see. This bool and this bool and this float are being pulled from the current state of your keyboard. So, okay. I mean, I would have just created the struct once and then just gone in, and I would have had a method saying, oh, pass in my little input data struct, and then I would go through each of these properties and just set them to the current state here. They're like throwing out each struct for like each fixed update, and they're like throwing the whole struct away and then creating a new one and then checking for user input. So it's a little bit of overhead that I don't think they should be doing. But ultimately what they're doing is every fixed update frame, they are filling these out. They're saying get the accelerate button, get the brake button. These are bools, if the user's pressing them or not, and if they're pressing the axis. So these get filled out. All right. I agree with that. Anyway, that was in awake. Oh, so awake just went through and just created it initially. And then in the fixed update, we keep like actively updating whether the user is pressing the buttons or not. Cool. So that was the awake. And so I'm going to stop there. And I am going to move on to fixed update in our next class. So I'm going to stop the video.